I hope you can see the slides now.
Yes, sir.
Yes, sir.
Yeah, so with a brief introduction to electronics and communication engineering, we started discussing the history of development of this field. And as you guys are aware, I also shared a PDF with you on Teams. That is all about, that's an interesting account, and that puts main inventions of electronics, main inventions of electrical and electronics engineering. And I hope you guys might have had a chance to go through that. If not, please go through that document. Uh, these things, I would say these things are not important from technical perspective, but these things are important from a philosophical point of view, from understanding this area from its beginnings and from its roots, actually. So please keep your mic mute, and if you have any question, you can unmute at any point of time and then ask the question. But if you don't have any question, please keep it mute. And this is what we saw, that electronics industry is one of the most fast-paced industries in the world, and it, in a way, fuels the development of computer science as well, computer technologies, because most of the developments in computer technologies, apart from algorithms, are supported by the hardware that sits behind it, and that is the core area of electronics industry. And apart from that, the communication technologies are also fast changing, and this is what we broadly saw in our last class. Essentially, the electronics is as uh, this is, I am just giving a quick review of what we discussed. It is, electronics is all about controlling the electrons. It is, or in more metaphorical sense, it is the story of conquest of the electron. I would not say the conquest, because the electron is not yet fully understood, in my opinion. It is still, we still don't know uh, everything about the elementary particles, but we know a fair bit, and that's why we are able to control and make use of them in our technologies. So, if we look at the story of electronics, it can be broadly divided in three eras, as we discussed in detail in the previous class. One is the so-called pre-electronics era, in which electronic devices were not there, transistor was not there, diodes and triodes were not there. But most of the science, or a good amount of science on which electronics rests, was developed in this time, uh, and in early 20th century as well. So, and that is known as the pre-electronics era. And in this era, there were some electrical devices and some rudimentary electronic systems, for example, radio waves. Then in the beginning of 20th century, vacuum tube electronics started coming up. And in 1947, uh, from 1947, the transistor era started, basically. So this is what we saw. We saw how this idea of electron and electric field was uh, gradually discovered or observed by various people and formalized. And so the first detailed documentation was done by William Gilbert in Britain in 1600s, and he is also known as the probably the first experimental physicist. Then, for almost uh, 200 years, various experiments happened. Benjamin Franklin in 1790s, he in a way demystified the lightning that happens from the clouds. Then in 1789, around after 200 years, Coulomb was the first one who put things in mathematical way. Up to this point, things were mostly theory. There were observations, and but a structured and formal treatment was not there, and it was first done by uh, Charles Coulomb in 1780s. Up to that point of time, magnetic field was not so formally understood, I would say, and the relationship between the electric field and the magnetic field was also not very clearly known. And so that's why this Coulomb's law are mostly concerned about uh, the electrostatics part only. When the charges are when electric charges are there, what will be the electric field and uh, how that will change once we change the configuration of charges. Uh, Slightly before Coulomb's time in 1750s and 1770s, bioelectricity was also discovered. Bioelectricity means that even in biological systems, even in living organisms, for example, in a catfish or in an eel, uh, uh, electrical signals or electrical current was felt by in some experiments, and you might have actually observed up to this point of time that many people uh, up to 1800s, they were not per se the chemical engineers or sorry, electrical engineers, or they were not so confined in a domain. So many of these scientists worked in chemistry, and they observed some anomalous things called electricity, and then they reported that. And similarly, in 1750s, 70s, even bioscientists observed electrical signals in living organisms, and that way, various fields. We can also see that um the roots or the scientific observation, or the way our understanding developed, has roots in multi-disciplines actually. Even so nowadays, electronics in itself is a big field, and anybody who is a specialist in electronics engineering or one of the domains of electronics engineering, it is very difficult to master any other discipline because in itself electronics is a huge field. But that was not the case in 1800s, or I would say up to 20th century. People were fairly uh, well versed in multiple disciplines, and I would say that if we have a multidisciplinary approach, that gives us a whole new perspective about science and also about the particular field that we are working in. So my point here is that even if your BTech is in electronics and communication engineering, I would suggest exploring all possible sort of all possible your interest areas. They may be in physics, they may be in chemistry, bio, or anywhere, metallurgical engineering, or anything. So nature doesn't have any boundary. These departments are just for the sake of sort of organizing things in a more proper way and dealing with things in a rigorous way. But our scientific curiosity does not have a boundary, so that's why explore everything, especially during your undergrads, and maybe in the later part of your undergrads, you can converge to one of the fields and then build your career in that field. Okay, so then similar experiments were conducted in Italy, even in British India. One of the British officers conducted bioelectricity related experiments, and that way, this confluence of biology and electrical engineering was sort of observed. Then in 1800, Alessandro Volta actually. So Volta was, I would say, the first one who uh, made a prototype of the modern day battery. It was one of the first inventions in electrical engineering. I'm not going too much into the details of what was actually done, and I would say that it is you guys might already be aware of these things. I'm just putting things in perspective. But if you are interested in a specific invention, you can go back and look up on the internet. A lot of information is available about each of these things. So the principle, yeah, there is a there seems to be a question. Any question? Okay, if not, uh,
From this part exam.
sorry.
So will we get questions in our exam from this part, from the history of
No, no,
electronics?
no. So, no, 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 definitely not. I also clarified this um, in our in previous class. Don't I would say, especially in this course, don't worry about the exams actually, because in other courses you should be more concerned about what would be there in the exam. In this course, as I said, there will be nothing will be there in exam from the history of electronics. It is this course is just to give you a perspective of the electrical engineering, electrical and electronics engineering, and so take this course from a philosophical and broad overview point of view, and maybe uh, to get familiar with the department itself. And that's why this course is designed to be a 2 credit course. And that's why only 2 classes are there for this course in a week, because this course is not exactly similar to the other courses. Uh, it doesn't mean that we will not have exams. We will definitely have exams, and exams will be will I would say more on more technical stuff, which we will start maybe by the end of today's class or maybe in next class. Okay. So in history, no questions. It is not a history class. Your history knowledge will not be judged. It is just to explain the story of the field that you have started, that you have chosen for your career actually. So this is just to give you an idea of that. Okay. So later, Humphrey Davy in Royal Institution London, he conducted various experiments actually, and uh, also used the battery developed by Volta. Davy in itself uh, was a good inventor actually, I would say, and then the understanding of magnetic field also started developing around this time. Although magnetic field was uh, the people knew that there is a thing like magnetic field or uh, and which can deflect the compass, but the formal understanding of the magnetic field was not there. And in 1820s, uh, Oersted in Denmark observed or demonstrated that uh, that when a current is flown through a wire, then this current basically deflects the compass. So a current carrying wire has an impact on the compass that is sitting beside the wire. So which means that this electrical property or electrical thing is having an impact on the magnetic property of a material. So there might be a relationship between electricity and magnetism. So that was the first observation uh, about the relationship between electricity and magnetism. Then around the same time, Ampere observed and reported that if there are 2 wires and the 2 wires are carrying currents in the same direction, then they will attract each other, and if uh, they are carrying currents in opposite direction, then they will repel. So, and that was only explainable by invoking the magnetic field, by invoking the idea of the magnetic field. And this is the point when electricity and magnetism, electric current and magnetism started converging with each other, actually. And then the major experiments, and I would say one of the greatest scientists in 20th century, uh, Michael Faraday, he conducted various experiments, and Faraday has an interesting story, and I would recommend everybody to go back and maybe go through the story of Faraday. He started his career at a bookbinder's shop, and he was not a very formally educated person. He did not study science formally in a university, as far as I know. He started working with Humphrey Davy in his lab, and but his intuition was very strong. His intuitive capabilities, his qualitative understanding of things was extremely exceptional. Was exceptional actually, because Even it is said that many of the inventions or many of the discoveries of Humphrey Davy were actually done by Michael Faraday. And Faraday was also the first person who invented a prototype of a motor. And he did experiments on chemistry or electrochemistry. He is also considered to be the father of physical chemistry or electrochemistry, and he presented many experiments and observations. Although, as I said, he was not formally so strong, so he did not describe those things in mathematical terms, only qualitatively, and but with great intuition, with great understanding and good explanation of things. So he also worked on electrolysis. Also, some people say that he invented electroplating on metals. And in addition to that, as I said, he was also involved in electrochemistry and chemistry experiments. He was also he played key role in discovering the ring structure of benzene, which was a big deal at that point of time. And even though Volta proposed a battery, he could not properly explain the mechanism of the battery. Actually, he intuitively or he sort of broadly understood what a battery is, how it would work, but he could not properly explain. That was also explained by Faraday. And because of his tremendous contributions, Faraday became the new director of the Royal Institution, London in 1829, and he also discovered the idea that there might be electric force lines, electric field lines, and magnetic field lines. So up to that point, nobody could imagine that electric and magnetic fields could be there everywhere in the space. They could be ubiquitous. They could be everywhere. There could be lines, invisible lines of these forces. And Faraday, although he did not understood these things mathematically, he intuitively hypothesized that even the light is made of oscillating electric and magnetic fields. Although he did not have a proper explanation why he thought so, but this was his intuition, and this is the first time that the connection between electricity and magnetism was properly presented. Although it was observed earlier, but Faraday was the first person uh, who qualitatively explained this thing in a more structured way. Okay, so so actually he was one of the founding fathers. He is one of the founding fathers in various fields, in electrical engineering, in chemistry, in bio, and in many things actually. Uh, Also, he was a very decent citizen. He did not apply. Uh, he never applied for a patent, and you might have heard or you might not have heard that at that time, around 1850s, there was a race amongst various scientists for applying for patents and establishing companies based on electrical engineering. So whenever there is a new science, there is a new technology that is discovered, there is a corresponding growth in industries. Many companies come in that field, and around that time, many scientists, for example, Edison was one of the Thomas Alva Edison was the one who, after his invention of electric bulb and many other electrical related inventions, he established his company, Edison's company, and he actually made a lot of money out of that. He also invented the DC current based lighting systems in households, and uh, he established companies. People used to publish patents, file for the patents, and claim royalty. And but Faraday never did so. And although he could have patented motor and many of his inventions, uh, he, however, could not formulate how electric and magnetic fields were transmitted through space. He could imagine, or uh, he proposed that there are electric force lines and magnetic force lines in the space, but how they propagate through space from one point to another point over long distances, that's what he could not explain in uh, and that's when James Clerk Maxwell actually comes into the picture. He was born in 1830s. Faraday was around 40, 50 years of that time, and uh, or maybe even older. And so Maxwell, as I said, Faraday was a great intuitive scientist. He understood things very well, qualitatively and intuitively. And Maxwell was one of the finest mathematician of 19th century, and it is said that he's amongst the finest physical mathematician, physicist, the uh, uh, the physicists who use mathematical tools. And he essentially, some people say that in his young age, discussions with Faraday, and he also, in fact, he also made very accurate predictions about the rings of Saturn at a very young age. And after elaborate discussion with Faraday, and he put together the ideas of Faraday and Ampere, also Gauss, and around after 11 years, he came up with the Maxwell's equations. And Maxwell's equations are the actually that is the breakthrough of our field. Not only electrical and electronics engineering, it was also a breakthrough in physics as a discipline, because it was the first time when the electricity, magnetism, the fundamental forces of the nature were unified and were presented mathematically, described accurately actually. And uh, initially, Maxwell actually gave 20 equations. Nowadays, we are all of us are aware of Maxwell's four equations for electromagnetism. Uh, do you guys remember those four equations?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah, those are essentially the building blocks, and
Yes, sir.
those equations, yes, they are still, there is no modification, so to say. There is that unification, that formalism of Maxwell still stands true. Initially, 20 equations were given, and later, uh, British scientist Heaviside, he sort of condensed after removing the redundancy in the equations. He condensed those 20 equations in four equations of Maxwell, and that is uh, uh, it was actually, you might have also heard that Maxwell's equation, once the Maxwell's equations were given, people of that time thought that the science is almost over now. We have all understood everything now. That was actually the pinnacle of science in 19th century. It was around 1900s or slightly before 1900s, late 1880s, 1890s. And scientists, especially physicists, used to think that now we have understood almost everything. We have understood electricity, magnetism, unification, propagation, everything is now understood. And as you might be aware that after few years came relativity in quantum mechanics, and then everything was again sort of in oblivion. Everything was again everybody was again starting from the scratch. Everything was again being reformulated from the beginning. But it was the Maxwell's equation which gave this feeling that the science is almost over. We have almost understood everything. And as you might have also observed that from the time of Gilbert, the first time when the electricity magnetism were formalized, it took almost 3 centuries in which these two forces of nature were properly understood and mathematically modeled, presented. This was also the time when the various inventions started happening, 1870s, 1880s, and various companies, various entrepreneurs, scientist entrepreneurs started coming up. And uh, but although these Maxwell, Faraday, those were not of this sort. Second important contribution after Maxwell was by Hertz. He discovered, or these radio waves or electromagnetic waves were already mathematically were given uh, by Maxwell, but they were not experimentally verified actually. experimentally, people only thought that electromagnetic waves, the light waves are electromagnetic waves, and only visible waves are there. The waves or visible spectrum of the light is only there. But according to Maxwell's equations, there should be other frequencies of light, other frequencies of electromagnetic waves, which are not observable to us with our eyes. But that was not experimentally demonstrated, and it was done by Henrik Herd, and that was also a big breakthrough. Also, actually, uh, this also triggered the invention of radio and television. And Hertz, in fact, created radio waves, and he essentially observed that the radio waves and the light waves are exactly the same thing, but with different frequencies. Then in this sequence, the gamma rays, microwaves, X-rays, all this electromagnetic spectrum was discovered, and uh, yes, and this is what actually went up to the advent of quantum mechanics in 1920s. So up to 1920s from Hertz, it was thought that this understanding of electromagnetic field was almost over. In between, in 1905, when Einstein actually presented papers on relativity, that also shook physics, and that also changed the understanding of mechanics fundamentally. And so Einstein in itself was one of the, in himself was one of the greatest scientists of all times. And just as a fun fact, Einstein had the portrait of three people. He had pictures of three people on his wall. One was Faraday, second was Maxwell, and third was Arthur Schopenhauer. So he was this third person was a philosopher, German philosopher, and Einstein. He had great influence on Einstein. So that essentially shows the contributions or the magnitude of the contributions of Faraday and Maxwell on physics and electrical and electronics engineering. And as I said, Faraday was not specifically, he was a chemist, he was a biologist, he did experiments on many fields. He was in a way polymath of his time. Okay. So this was essentially the foundation on which electronics essentially was built in the 20th century. This is the foundation that was laid by Faraday, Maxwell, Hertz, on which the electronics sort of rests. Any questions? I guess somebody. If not, we can move on. And this essentially ends the pre-electronics era. In this era, there were some inventions, as I said. The first of those inventions was the invention of telegraph in 1850s, I guess, 50s, 60s. And telegraph was essentially the transmission of text messages via electrical signals over long distances. It was formulated by Morse, and that's why the telegraph codes are known as the Morse codes. Then in 1870s, telephones were discovered. Telephones were invented or discovered, and the invention of telephone is attributed to two people, Elisha Gray and Alexander Graham Bell. Uh, telegraph was transmission of text messages. Telephone was transmission of audio signals over long distances, and that was also done using electrical currents, electric fields. Uh, uh, then after Hertz discovery, even the radio uh, and radar systems were discovered. Also, the television was also first demonstrated around that time. But there is an interesting story uh, that uh, once the Edison, after the invention of light bulb, he essentially set up an entire company on based on DC current. So generally at that time there were, uh, hello, any questions? Yes. So at that time, both AC current, DC current were popular, and generally in US, uh, they used to have high voltage AC transmission for street lights, and they used to have low voltage DC supply for household lightings, and uh, and there was a great competition between the AC and DC currents, so to say, or the companies behind these currents. That is also known as the war of currents, I guess. If you search the war of currents, that is essentially the war between the AC current, domination of AC current and DC current. And the DC front was being led by Edison. The AC front was being led by Westinghouse. So the AC was used for street lights, DC was used for domestic lights, DC was low voltage, AC was high voltage. There were some shortcomings. It was extremely expensive to produce and transmit DC current. AC current uh, was more dangerous, so to say, because there used to be at that time it was reported in media that there were many injuries because of the high voltage AC transmission lines. But at that time, Westinghouse, his company discovered transformer, invented transformer, and that was again uh, a big turning point because with the help of the transformer, high voltage AC current could be stepped down to low voltage AC current. And so that way the AC current could be was available both at high voltage and low voltage. Now the only thing that was left was uh, to convert the low voltage AC to DC so that the house lightings could work properly. And that's when, for this conversion from AC to DC, that's when this diode was discovered. That's the first electronic device uh, considered by scientists. That was mainly motivated for conversion from AC to DC current. And because of that, because of transformer and this AC to DC conversion, the DC current, the Edison's company actually was left way behind, and there were many legal battles between Edison and Westinghouse as well. They filed case, patent breach, but ultimately the AC technology won, and nowadays, as you can see, we just have AC transmission. I would recommend, if you are interested, you can go back and you can search for the war of currents or the AC DC war. So if you search any of these, you will find what was going on in late 19th century, and they made huge amount of money from these inventions actually, because uh, just imagine that in 1850s or even before that 1860s, there were no electrical lightings, only candles and oil lamps. Those traditional lightings were there. Suddenly, in 20, 30 years, the entire country was being uh, uh, installed with uh, the street lights, domestic lights, and that was a huge actually business at that time. Finally, the Westinghouse company won, and the AC, we have AC for transmission. Tesla also played crucial role in this AC domination. Uh, Around the same time in 1870s, 80s, Marconi, it is said that the Marconi uh, demonstrated the transmission of electromagnetic waves up to 3 kilometers, essentially the invention of a radio or uh, but at the same time, J.C. Bose uh, in Kolkata also actually demonstrated this transmission of electromagnetic waves. And in fact, it was said that it was J.C. Bose who first actually did this, although his contribution was not acknowledged for a long time. And a Russian scientist, Popov, and J.C. Bose, in fact, both of them independently did it before Marconi. And nowadays it is being acknowledged by the international community as well. If you search about J.C. Bose's um, invention. Especially, he actually invented the receiver, the mercury-based receiver for electromagnetic waves. And using that receiver, it is said that Marconi uh, 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 essentially demonstrated the electromagnetic wave transmission and detection. Okay, although the contribution of J.C. Bose were not acknowledged for a long time, J.C. Bose also worked on plants and the electric signals through plants, their sensitivities, also made seminal contribution in that field. And the instrument that he made is, I guess, known as crestograph, the instrument that senses the signals being transmitted by plants for various responses. Uh, if you are interested, many great contribution of J.C. Bose were not acknowledged for a long time, although eventually, and now everybody acknowledged that. Even IEEE formally in one of their issues acknowledged that J.C. Bose was in fact the father of communication and not the Marconi. Because essentially in communication technologies, uh, we need to send a signal, we need to send a modulated signal or a raw signal, and that is sent via electromagnetic waves. So we need to have a transmitter, we need to have a communication channel, we need to have a receiver, and the first of those demonstrations were given by J.C. Bose, and building on that, Marconi actually developed. Although Marconi received Nobel Prize because at that time J.C. Bose's contribution were not acknowledged. Um, so this is essentially what it is. And as I said, these guys are the like the founding fathers in this domain. And uh, the beginning of 20th century was very interesting from technological and from scientific point of view because at that time this AC/DC war was almost was at peak, and in order to convert AC signal to DC signal, vacuum tubes were invented very early in the beginning of 20th century. And apart from that, Einstein's relativity and soon after that quantum mechanics, these electronics, relativity and quantum mechanics, all of them came up in the early 20th century. And that was again, uh, that changed everything. And again, we again after especially after quantum mechanics and relativity, uh, it was again, I would say, a restart for the science because they shook the foundations of the science that was known up to that point of time. It actually made us realize that we knew a very we knew what we knew was actually either inaccurate or incomplete. Okay, so that essentially ends the pre-electronics era, the discussion of pre-electronics era. We will not go into too much of the details of the vacuum tube electronics era, which is essentially but let me quickly, just for the sake of completion, uh, it was Fleming in 1904 who demonstrated a vacuum tube device. And these are very important devices. And mind you, uh, even though transistors might have replaced the vacuum tube devices, but there are very specific and niche applications of vacuum tube devices. And even today, vacuum tube devices are used, especially in high frequency and high power applications. And those applications are mostly used in defense sector and in the aerospace sector. Okay, so these devices are used even today. So it's not that they are completely out of the scene. Although the main functionality, uh, the uh, the AC to DC conversion or the diode rectifier function, that is also known as the rectification of the electrical signal, that is no longer done by these vacuum tubes, and the triodes are totally replaced by the transistors. Okay, so in 1904, Fleming essentially made a glass tube in which there was an electrode which was heated. This was known as cathode, and on being heated, the cathode emits electrons. And there is another electrode, a metal rod, so to say, a metal plate, where we can apply a positive voltage or negative voltage. If we apply a positive voltage on anode, it essentially attracts electrons towards it, and that results in the current flow through the device. And when we apply a negative voltage or zero voltage also, the current is either not there or very less in amount. Okay, so that way, if we have an AC signal in which both positive and negative values of the current are there, so during the positive cycle, and if we apply the AC signal on the anode, during the positive cycle, we will get a current through this device, but during the negative cycle, we will not get any current. And that's how an AC current is converted into a DC signal. Okay. So, and this device is considered to be the birth of electronics, as I have mentioned. Soon after vacuum tube diode, a vacuum tube triode was invented by Forrest in 1906 in US. And apart from these two metal plates, there was an additional third metal rod in between, which by applying a voltage on this third terminal, we could control the flow between the two other terminals. Okay. Any questions you might have?
No, sir.
Okay. So this is how a triode looks like. Apart from these two electrodes, apart from cathode and anode, we have a third terminal as well. This is known as the gate terminal nowadays, and this was a sort of a grid. Grid means metal plate with holes in between, and when the cathode was heated, if there is a positive voltage on the gate, it will attract electrons and it will push them towards the anode, and it will facilitate the current flow from anode to cathode. Okay, so in this device, in the vacuum tube triode, this third terminal was like a control terminal, and a small signal fluctuation on the third terminal could result in large fluctuation on the two other terminals. So if we apply a small AC signal on this third terminal, it has huge impact on AC signal on other uh, two terminals. Okay, so that way, and that is essentially the principle of transistor as well. So transistor in a way was inspired from this three terminal device from the triode, and this functioning when a small AC signal results in large AC signal, this is also known as the amplification. Okay, so a vacuum tube triode could achieve amplification. A diode could only achieve switching. Switching, it means that it can switch off when there is a negative voltage on anode, and it can switch on when there is a positive voltage on anode. Okay, so both switching and amplification functions are essentially the defining features of the transistor. A transistor also achieves these two functions, and uh, but the problem was that the problem with these devices was that these devices were very big in size as compared to a solid state transistor, because we need to make a glass tube, we need to make vacuum inside that, create vacuum inside them. We need to put metal plates, then connecting rods, then heating supply. That made these devices large in size. Also, the glass tube was breakable easily. They needed high maintenance actually, and in fact, uh, computer was invented based on triodes. You would not imagine it involved thousands of triodes in a big room. Thousands of triodes were connected in a certain way so that we could achieve basic computational functionality, basic logic operations could be performed. And but the problem was that in those thousands of tubes, one or two tubes would definitely be non-functional at any day, and it was extremely tricky task to identify the non-functional tubes and replace them. So that is also that vacuum tube triode based computer is also considered to be the first experimental demonstration of a computer. Uh, Apart from computer, the diode and triode essentially uh, resulted in the invention of radio communication technology, because they could operate on high frequency, the television, where not only audio but video signals, both audio and visual signals, could be encoded and sent, and then again decoded with the help of a uh, with the electron beam, electron gun, and radar technology. These technologies were driven by the vacuum tube invention, and that
Sir,
is uh, yes,
sir, so triode rectifies as well as amplifies, no?
yes, triode can rectify and amplify. So triode can work as a diode any day. So if we apply 0 volt on the third terminal, it is a diode. And if we apply any other voltage, it is a triode. It gives a triode function.
Okay, sir.
Okay.
Yes, sir.
Yeah. So then in 20th century, early 20th century, as I have already mentioned, that the fundamental understanding of the nature was revolutionized, because the photoelectric effect, which essentially told us that the nature of there are electronic levels, there are discrete levels of energy uh, in atoms. Also, the light is also quantized. The light has a specific quanta of energy, specific amount of energy, and that's what triggered the discovery of quantum mechanics. And quantum mechanics fundamentally changed the understanding of the nature. So, are you guys familiar with basics of quantum mechanics? Have you done any course previously, or
No, sir,
anything that you
not
know?
yet.
No, sir.
No,
Sir.
No,
But
sir.
this, yeah, theory of atoms, and in chemistry, it might have been taught to you in some details. The theory of bonds. Uh,
Yes, sir.
yeah, so that at least you understand that quantum mechanics changed everything in a fundamental way when it came, because before that people used to think that there are continuous energy levels, there are uh, how an atom is made was totally unclear, but quantum mechanics essentially established the discrete nature of energy levels in the atoms, and the quantized nature of light. uh, Also, quantum mechanics is also very interesting. Now, after around 1 century, it has been almost 100 years now since the quantum mechanics was discovered. And now, if you do a quick search on internet, and if you search quantum technology, you will find thousands of results. So, after around 90, 100 years, now technologies based on quantum mechanics are coming up, where quantum effects are being used for technological applications. And that is also the next upcoming big technological paradigm that we will possibly see in coming 20, 30 years. Quantum computers, you might have already heard about. So quantum computers have been demonstrated at big corporations. IBM, Google, all of them have uh, a quantum computer, at least 50 to 70 qubit quantum computer, and that is based on quantum mechanics. So the science was, even though the science was uh, discovered, or science was formulated 100 years, it is after 100 years that the technology is coming up in quantum mechanics. Okay, so Then came and I should mention that quantum mechanics, the discovery of quantum mechanics, the formalism of quantum mechanics is due to primarily Max Planck, Einstein, Bohr, Niels Bohr, de Broglie, Heisenberg, Schrodinger, and Paul Dirac. These were again the great men of 20th century, great personalities, apart from many other scientists. And it's an interesting article. If you the link, the Wikipedia link of the article is this: History of Quantum Mechanics, and uh, then later Feynman was one of the major contributors. Then came the world wars. Actually, in 1915-14 was the first World War, which essentially had the seeds of Second World War. And then in 1939, the Second World War came up, and because of the Second World War, a lot of technologies, a lot of inventions were done. So 1920s to 30s was the time when quantum mechanics was being formulated, and after 1930s, because of the war-like situation, huge number of discoveries and inventions were done for especially for the war technology, which were later used as civilian technologies as well. So it was so the transistor was the idea of transistor is pretty old. It is as old as the idea of a rectifier, AC to DC field. People always thought that by connecting different kind of materials, we can make a rectifier in which the current can go in one direction but cannot go in other direction. But it was not invented, and then these vacuum tubes came up. Vacuum tubes essentially filled that lacunae of a rectifier. But soon after the discovery of vacuum tubes, people realized that the application of vacuum tubes is limited because, as I said, because of their size and vulnerabilities. And that's when again the focus went to the solid state rectifier. And uh, so it was first in a very rudimentary form by Brown in 1874. It was demonstrated, but it was a very bad rectifier. The idea, however, is the same as a PN junction. And the problem was that the contact between two materials is, as all of us know, that when we combine two materials, the atoms on the surface, the atoms where the junction is there, it is very important to match, to properly build this junction. Otherwise, there are lots of vacancies, there are lots of dangling bonds, electrons flow cannot be sustained if this junction is not proper. So essentially, the discovery of a PN junction or the discovery of a transistor was mostly about making a good junction of two materials. Okay, and that took a lot of time. And after 1930s, a lot of push was there, especially in the Bell labs. Then, then quantum mechanics actually, after 1920s, quantum mechanics provided a very good understanding of solids. And out of solids, people now properly understood that there are some materials which are metals, there are some materials which are semiconductors, and there are some insulators. Why they are like that was also being understood. And so that way, the understanding of solids because of quantum mechanics, that played a key role in the development of the transistor, the solid state transistors. And in 1936, at Bell Labs, this group was started to make a solid state triode, so to say, solid state transistor. Then in 3 years, the war started. This group was stopped. For 3 years, they could not achieve much. Independently, German scientists Paul and Hilsch were also working on the same thing, almost the same thing. And they actually reported a three-terminal amplifier. Uh, these German scientists reported a three-terminal amplifier way before the transistor was reported in US, and but the problem was that their operating frequency was very low, and it was not also properly received because during war, Germany was on the other side of the war, and the communication between Germany and the rest of the Europe and US was not proper. Then again, after the war, uh, this group was again started, and after 2 years of the war, uh, the first transistor was essentially demonstrated by these three guys, Bardeen, Breton, and Shockley. Shockley was the leader. Bardeen, Breton were the engineers. Shockley, in fact, Shockley was trying to do this thing since long time, since many years independently. But because of the genius of Bardeen and Breton, because of their practical knowledge of solid state materials, uh, they could jointly do this in 1947. Although Shockley took most of the credits, but the credit also goes to Bardeen and Breton, and that is essentially the start of the modern day electronics engineering. And in November 1947, uh, the transistor was first demonstrated. It was improved within a month, and next year, June 1948, they had a press conference in which they demonstrated a small circuit made from the transistor and a small mic, essentially, where the voices could be amplified. Small microphone was demonstrated in June 1948, and that was, I would say, the starting point of the modern day electronics. So this is all about the story of electronics engineering, and then came the uh, integrated circuits, which is again was an important step in this story. So we will discuss this, and from next class onwards, we will start with the basics of the semiconductor materials. Uh, why semiconductor materials are crucial in electronics engineering, and how do we sort of make devices and circuits out of these semiconductors. Okay. So that's all for today. And if you have any question, please let me know. We can discuss. Also, I would recommend all of you to start working on your, uh, start identifying a course project as well. So this semester, what I'm thinking is that uh, so for those of you uh, who can avail facilities, who have access to equipments, and we can also help you out in that. You can make a small, maybe a line follower robot or small uh, working electronic system robot, maybe a small drone you can assemble on your own. Don't buy it from the market. Or if those things are not available, you can uh, you try to find a device, maybe a dysfunctional, a non-functional mobile phone or laptop, and start investigating that. Start maybe opening it and uh, find out what is all there in this, what is the function of various modules, various chips, what is there inside the chips, search over internet. So after the meet and greet video, start working on that as well. And this is a semester long, and as I told you that it has major contribution in your marks, around 40 marks, 35 to 40 marks for this project. Okay.
Okay, sir.
Yeah, so you will have around a week or so after your videos, you will have around a week to finalize your projects, and then you can start working on that in a more focused way. But just have a give it a thought uh, in your free time. Any questions?
Then what are the
Sir,
topics?
after making the opening the mobiles or so some gadgets like that, sir, what we have to do with the research? Sir, we have to write a report or PPT. What we have to do?
Yeah, so we will have regular discussion sessions on what you are observing, what you have seen, what you have observed. Generally, in today's electronic equipments, generally most of the things are packaged. If you open up a mobile phone, you will see various sections there. You will not see exactly transistors there. You will see packaged modules, dedicated modules. Then you need to study those modules on internet or in books. What is there in the module? What is the circuit structure? What is the functionality? How it is working that way? Those kind of things. So
Okay, sir.
the TAs and I will be available for that discussion during the entire semester. So don't worry about that. Just uh, since all of you are at your homes and the conditions at your homes are different for all of you, I would say. Everybody has unique conditions. So uh, try to identify uh, at your home. And then once finalized,
Sir, your
get
voice is not clear.
more discussion on that.
Sir, can you please repeat, sir? I
Sir,
was not
again,
able to.
Sir, you had a connection issue.
Sorry,
yes, sir.
which part should I repeat? Which part?
So the last part you were
So
talking
the
about.
last part when you said that different conditions at different places from there.
Yeah, so what I'm saying is that that in the online semester, everybody cannot be given the same project or the similar projects. So I would recommend all of you to identify an appropriate uh, project for you. It should be challenging. It should have good amount of decent amount of work. And once you finalize this, then we can have discussions. I and the course TAs, teaching assistants, who are your seniors, will be available for the discussion during the entire semester. Okay.
So how many projects we will be making for one semester?
How many? Sorry.
Course projects.
So for this course, only one project will be there.
For first semester.
Yes, for this. So this course is only for the first semester.
Okay, sir.
Any other questions about the video or about anything else?
So like you told about the line follower robot and things like if we don't know about the like coding side of these things, so can we take it from the internet?
Yeah, coding you can discuss with the TAs as well, with the TAs and also from the internet. But you need to arrange the hardware on your own. We can, if you give the receipts, the what you purchase, we can give you some amount. We can reimburse some amount of money to you if this money is not too huge. But if you can avail hardware from your maybe your neighborhood or from internet online, that will also be good. Coding you can discuss with the TAs and also consult the internet. Nowadays, internet has lots of things. There is no harm in
So do you know
going there.
any online website which sells good quality of?
Yes, yes, exactly. That's a good question, and I will share some of those things with you maybe next week. Uh, yes, some of those
Okay, sir.
websites.
So like in the earlier classes, I had searched about these line follower robots and like that. So I found out like there are like pre-made codes about these things. So is it allowed to import those codes directly?
No, I would say that don't import a pre-written code as it is. Try to understand the code and write it on your own, maybe. So it may be quite similar to what is there on the internet. But please write the code on your own. That would be better.
Sir, is Arduino allowed?
Yeah, definitely. You can take help of Arduino or anything. This is quite a blue sky. This is, yeah, don't take it from the exam point of view. Exam is just, I would say, a byproduct. Just this is just to sort of understand the science in a free way. Because I do not believe that that entire grading should be done by exams only. Because in exams one can just mug things up and score well. But that doesn't mean that the understanding of that particular subject is good. So that's why this course project is there, so that your exam load is less and your practical understanding is more. Okay.
Sir, what will be the deadline for making course project this one?
This is an entire semester long thing. You can uh, so since the weightage is also good, so you can take the entire semester. So maybe just before the end of this semester, before your end sems, we will have the final summations or final thing about it.
Okay, sir.
So will there be groups made like this work will be done by this person and this work will be done by this person? Like these
No,
things?
as I said that these projects are totally individual, so everybody has to do one project.
Okay, sir.
Okay, and do not
Sir,
sort of copy
sir,
your.
sir, if campus happen to open after the midterms, so can we change our project and work on drones and something like that?
Yeah, definitely. Yeah, you can do that actually, but those things are not sure at the moment. Nobody knows. But up to the end of the semester, and if the campus opens up, you can definitely uh, you will be given. Although you will get less time, so there might be you might get less time in making, and that's why you would maybe need to devote more time in that case.
Yes, sir.
But you can do that. There is a lot of freedom in this course.
Yes, sir.
Anything else?
Sir,
Yeah.
sir, as we don't know how to make robots or drones, so do we need to take help of internet?
You can, as I told, you can take help of internet. You can also discuss with the TAs. I will put you in touch with the TAs. And as I told that if the situation at your home is not suitable, by which I mean uh, that that you cannot avail hardware, you can maybe do another project which is not hardware oriented. You can uh, try to understand a mobile phone or a computer or something like that.
Okay.
Like, sir, you said that the project should be like minimum hard work is required. So what is the minimum criteria like?
Minimum hard work. I'm not saying minimum hard work is required. Hard
So
work should be there definitely. Hard work is required for understanding things.
I mean, sir, like you
Yeah.
said that it should not be
So
easy. Like, so
it
how
should
can
not be
we?
easy. Yeah.
So how can we check that? Matlab,
Yeah. For that we will have weekly or bi-weekly discussion sessions with different groups, different students. Okay. So the weekly progress or the status will be checked. So that will start once you submit your meet and greet video, and after that we will start that process.
Okay, sir.
Sir, you told that not to buy the whole drone. So,
Yeah, definitely.
so we can buy the parts of it from online website.
Yes, you can buy, for example, you can buy a motor, you can buy the wings, you can, but you should not buy the microcontroller part of it. You can buy the definitely buy the microcontroller, but you should put everything together. You should do the programming. You should optimize it so that you actually get a feel of how this is made, how this functions.
But sir, what if we don't know programming?
And how to assemble all the
Yeah. So
parts
in
and
that case, sorry, what is the next question?
sir, how will we learn how to put together all the parts and do the programming? Should we use internet for that?
Yeah, so there are two questions. One is if we don't know programming, as I told you that if you are willing to learn programming, that's definitely uh, preferable. And lots of resources are there. As I said, once you are in touch with TAs will definitely help you out in that. And internet is there. Nowadays, people can do many things just by using knowledge from the internet. So you can definitely uh, use internet sources. Okay. Even so, still, if you feel that you cannot do that at this stage, don't take a programming project in that case. Just choose something which does not involve programming. Maybe, as I told you, understanding an electronic uh, equipment, mobile phone or laptop could be of that sort. Okay, but I would recommend that most of you take a more challenging project,
Sir, which
and
programming
help
language?
will be given by. So yeah, generally it is typically if you know how to code in C language, you can easily learn the Arduino programming, which is quite similar to the C programming or Python programming. Okay, generally
Sir,
sometimes these
Sure.
programming is specific to the microcontroller as well. But there is so I have a small tip for you. If you know programming, decent programming in one language, it is very easy to learn in another language. It is just syntax change and the change of slight change of the framework.
So can we use Java to program?
Use Java.
Definitely, yeah. If your microcontroller allows, definitely you can.
sir, I know like a little bit of Python. So can I use that?
Yeah, that will be helpful. That will be helpful.
Sir, is there a official WhatsApp group in which you are added?
Uh, Official WhatsApp group for?
In which you are added, like just a batch group like this?
No, actually, do you guys have a WhatsApp group of your own?
Yes, sir.
Yes, sir.
So yeah, so in
Yes.
that case, it will be easy. So I'll ask the TAs to make a WhatsApp group so that all of you would be there and the TAs and I will be there in that group so that we can have these kind of discussions.
Okay, sir.
Okay, sir.
Anything else?
Sir, can you send a list of preferable projects, like what sort of project we have to make?
Yes, sir.
So I'll send you the list of projects done by your senior batches. Okay, so that will be maybe helpful for you.
Sir, will the projects like line following robot and drones in comparison to the mobile ones will be given better grades like that?
No. Don't worry about that. The grades will be given on the basis of amount of effort that you put in. So as I told that we will be having regular discussions and that will sort of tell us about the amount of effort and amount of understanding that you are gaining uh, and the grading will be based on that. Although if you do a new thing, the amount of understanding will be more. doesn't mean that the project on mobile phone will get less marks.
Okay, sir.
Okay, if there is no more question, maybe we can close this. And I guess there is a class tomorrow as well at 5 o'clock. So see you tomorrow. Bye.
Thank you, sir.
Yes, sir.
Thank
Thank
you,
you, sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.